So in this problem, we need to show that the following three lines are concurrent. Okay, let us begin. First, what we're going to do is we're going to name each of the three lines. So let us represent the first line as L1. So L1 is going to have the equation 1 over A multiplied to X added to 1 over B multiplied to Y. So we're going to transpose 1 from the right hand side to the left hand side to get -1. That's going to be equals to 0. All we are doing is writing the equation of the line in the general form ax plus by plus c equals to 0. Next, we have the line L2. So L2 can be expressed as 1 over b, that is going to be the coefficient of x, added to 1 over a times y. Similarly, we're going to transpose 1 from the right hand side to the left hand side to get -1, that's equals to 0. And then finally, we have the third line L3. L3 is going to be 1 times x minus 1, we can say positive, multiplied to -1 times y plus 0 equals to 0. So this is going to be the line 3 expressed in the general form. The reason why we're expressing each of the lines in the general form, because we want to form a 3 by 3 determinant. So let's say we have the 3 by 3 determinant. In the first row, this is going to be the first row. So here in the first row, we're going to consider the constant coefficients of the line L1. So starting with the coefficient of x, we have 1 over a. That's going to be the element in the first row, first column. Then moving on to the first row, second column, we're going to consider the coefficient of y, that's 1 over b. And then moving on to the first row, third column, we're going to consider the constant coefficient of, that's -1. In the second row, R2, we're going to consider the constant coefficients of the line L2. So starting with x, we have 1 over b, that is going to be the coefficient of x. Then we have the coefficient of y, which is going to go to the second row, second column. And then in the second row, third column, we're going to consider the constant term, that's -1. Finally, coming to the third row. So in the third row, we have the coefficient of the x in line L3, so that's 1. That is going to be placed in the third row, first column. Coming to the third row, second column, we're going to consider the coefficient of y, that's -1, the constant term being 0, so we put 0 in the third row, third column. Our next goal will be to expand this determinant. So we're going to expand it along row number 1. So what we'll do, we're going to consider the first element, that is the element present in the first row, first column, which is 1 over a. 1 over a is going to get multiplied to a 2 by 2 determinant. Now this 2 by 2 determinant can be formed by rejecting the entire row and the entire column that contains 1 over a. So if we reject the entire row 1 and entire column 1, so column 1, column 2 and column 3. So if we reject entire column 1, all we'll be left with 1 over b, -1, -1 and 0. So that gives us the 2 by 2 determinant. Then let's go to the next term. The next term can be negative of the term that is present in the first row and second column, which is 1 over b. We have 1 over b, that is going to get multiplied to a 2 by 2 determinant. The rule remains the same. We're going to reject the entire row that contains the term 1 over b. So R1 will be rejected and C2 also has to get rejected. And that leaves us with 1 over b, -1, 1 and 0. And finally, coming to the third term, we have positive. However, we have -1 present in the first row, third column. So we're going to place here -1. So this is going to get multiplied to a 2 by 2 determinant. For finding out a 2 by 2 determinant, we reject the entire row R1 as it contains -1 and also the column 3. So this is going to leave us with 1 over, so this is actually, there's a mistake. This is 1 over a. I made a mistake there. So this is going to be 1 over a. So we have 1 over b. Then we have 1 over a, 1 and -1. Right. So let's expand. Now we have 1 over a. So 1 over a times 0, that's simply 0. Minus -1 times -1, that's +1. Minus 1 over b, that's going to get multiplied to, so 1 over b times 0, that's simply 0. Minus 1 times -1, that makes it -1. But since we already have a negative sign here, we are going to get +1. Then we have positive times -1 makes it -1 multiplied to 1 over b minus 1. So that's -1 over b minus 1 times 1 over b, so that's positive 1 over a. Right, so let's expand it. So we have negative 1 over a minus 1 over b. So negative 1 multiplied to negative 1 over b makes it positive 1 over b. Added to negative 1 times negative 1 over a, so that's positive 1 over a. So all of these terms are going to get cancelled out, and that leaves us with 0. So what we have obtained, we have seen here that the determinant is 0, which is the condition for concurrency. So here we can say, so this implies that thus the lines L1, L2 and L3, the lines that we have considered, these three lines are concurrent. They must be concurrent. That means they are going to have a common intersection point.